Welcome to this new edition of the NLP Meetup. So first of all, we would like to thank Linkfluence to host us. So thank you, Linkfluence. And first information, maybe for you, if you want to connect to the Wi-Fi. So you can connect to the Wi-Fi named LF guest for 5G with the password Wi-Fi at CHORON, and it's written at the end. If you want. So the CEO of Linkfluence say some words about Linkfluence.
Yeah. So hi everyone. My name is Guillaume, and I'm the CEO of Linkfluence. So welcome. We're super happy to have you here. We're super bullish about NLP. I'm going to tell you why in a second. At Linkfluence, what we do is we're trying to understand the web. So we're a social intelligence company. We're trying to help brands understand how people online talk about them, their competitors, what are trends that can be important for them. So you can guess from that description that there's a lot of NLP and also some computer vision as well involved into this. So we're super happy to host this. To give you a sense of like where we operate, we're a company operating in Europe, Asia, and now in the US as well, about 200 people. We're serving brands like LVMH, Kering, Danone, Toyota, so large global consumer brands. At the core, one of the things that fascinates me about this mission and the NLP part is, so I'm an engineer by training. I don't code anymore, unfortunately. But one of the first computer science project I worked on was machine learning to try to get some patterns out of finance data. And I believe there's fundamental, really interesting things happening right now. Our mission, like I like to say, is to fundamentally understand understand the web. And I think NLP is really exciting, going through exciting times. So I'm going to stop there, let you have the conversation you deserve. Welcome. And if you have any question around Linkfluence, we'll be around for a bit more. Thank you.
Thank you. So tonight we'll have two great talks, and that way we'll start with Alexis from Linkfluence. So please welcome Alexis.
So can you all hear me? Okay. So well, I don't need that, right? Okay. So welcome everyone. Thank you to be here for the 5th Paris NLP Meetup. I'm Alexis from Linkfluence, and that's not working. Okay. And today I'm going to present our work on multilingual sentiment analysis and emotion detection using emoji as universal sentence representation for social media data. So I'll begin with a little introduction to present the why, what, and how did we launch the project. I will focus on the Deepmoji, which is a Deepmoji approach, which is a paper, and then I will go on our internet challenge. How can we adapt this paper for our internet challenges? And this resulted in our approach, Unimoji. Finally, I finished with conclusion and perspective. So I will pass this slide as our CEO presented it well. Okay, so I'm an AI engineer here at Linkfluence, and our work consists in two different parts. The first part, the research part, where we read papers, we do some technological watch, we prototype new features that will be then integrated in our product. We train the models, obviously, and we do some science popularization. And we also do the other part, which is the production part, where we implement the feature that we prototype actually in the production pipeline, either to be real time or either in batch computation if we don't have the real time constraint. And another cool part is that we own our pipeline, so we have the responsibility to enhance it and do some code optimization to make it scalable, etc. Here are the different technology we're working with. So there are big data frameworks, research stuff, different machine learning and frameworks that we are using, and we are programming on some fancy programming language such as Clojure or Scala. So let's go in. This is our pipeline. Here you have a sample of the blocks that our pipeline contains, and you've got some language detection, extraction, entity linking, opinion mining, categorization, and location and user inference. And in this block, you also have some sub-blocks. For example, in the location and user inference block, you will have gender inference, age inference, whether the account, the Twitter account, for example, is human or not. But the most important here are the statistics on the right, because that's really important that you understand that we have to process around 1,200 documents per second in more than 60 languages, and these documents come from 10 different platforms, social media platform or the web. And in all these blocks, there are, for the moment, more than 65 models that run doing real-time inference. And as you might have guessed, today we'll focus on the opinion mining block, and more precisely on two tasks. The sentiment analysis task, which is a document level sentiment classification between 4 classes: positive, negative, neutral, and mixed. The goal is to, being given a text, infer one of these class, trying to get what the author tried to emotionally explain in this text. And we also talk about emotion detection, which is also document level classification, but this time it's a multi-label classification. So we won't try to infer one emotion that is present in the document, but actually there might be different emotions. For example, anger and sadness expressed in the same document. And so why did we launch?
Yes, maybe after.
Okay. So why did we launch this project? The first goal, the initial goal, was to enhance our sentiment analysis algorithm that was running in our pipeline and that was getting quite old. And as you might have guessed, working with social media data brings some challenges, such as the social media posts are really dirty data. You've got many posts with spelling mistakes, grammatical errors, grammatical contractions, abbreviation, the specific terms such as hashtags, mention, etc. And for opinion mining on social media data, you have very few annotated corpora data available online. And this different corpora contains very few examples, from 100 to 1,000 in general. And one more thing is that the majority of these corpora are in English and domain specific. For example, you will have some data set on sentiment analysis for, I don't know, nuclear energy. And this is a real problem for us, because we want to, ideally, to perform sentiment analysis on more than 60 languages and on the whole social media ecosphere. So this is really for the sentiment analysis task in social media data, we really, as in a lot of machine learning field, we are limited by the manually annotated data. So first question, how can we leverage this lack of annotated data? Well, we were not the first who asked ourselves this question, and there exist some techniques that were developed through the time. using some distance supervision to automatically label high volume of data automatically, and then to perform opinion mining on it. For example, in 2012, Mohammed used specific hashtags such as good and bad to automatically label data. So if the post was containing, for example, the hashtag good, then it was automatically labeled as positive. And more recently, we've got Deryu and Teng that use quite of the same techniques, but using different objective for the annotation. They were using negative or positive emoticons or emoji sets. So, for example, if your post was containing a smiling emoji, it was labeled as positive. If it was containing a crying emoji or an angry emoji, it was labeled at negative. And this worked actually quite well to really get a lot of training data. But it was working quite good, so our previous sentiment model was based on this approach. And the major drawback that you can see is that if we use this technique to automatically label data, then we will have a problem to get, for example, sarcastic content. And that's what Felbo in 2016 tried to tackle with the Deepmoji model. So with this model, actually, we will talk about it more later, but they pre-train a model to predict from being given a text an emoji probability distribution, and this they show that this emoji probability distribution actually encode emotional context of the text. So as the Deepmoji also says, through Deepmoji they managed to leverage the power of emoji to accurately encode the emotional content of the text. And how do they do that? Well, they predefined a set of 64 emojis, and they extracted 1.2 billion of tweets with each tweet containing at least one emoji that was in the predefined set. And they created a big training data set extracting the emoji that was in the set and put it as a label. And then they pre-trained the model to predict an emoji probability distribution given the text. You've got an example on the right. And what they do after is that they fine-tuned their model that was that learned a lot of emotion to encode emotional context, and they fine-tuned it on different opinion tasks. So actually 3: sentiment analysis, emotion detection, and sarcasm detection. You might wonder what does the model look like. Well, it's a very simple two-layer BLSTM with an attention layer. It's actually a weighted average attention layer on the hidden states of the different average on the average the hidden state of the different BLSTM layers, and performing attention on that. And then they use transfer learning, as I said, fine-tuning. They do a special kind of fine-tuning that they call chainsaw. It consists in sequentially freezing a layer and retrain the model on the target specific task. Why is that cool? Because Deepmoji, I didn't say it, but we started this project 7 months ago. So it was before the Bert's arrival, and at this time Deepmoji was state-of-the-art on the 3 NLP, 3 opinion mining tasks: emotion detection, sentiment analysis, and sarcasm detection. And this was a really good fit for us because for our use case, opinion mining on social media posts. And moreover, it was a very simple and easy to read code written in Keras that was really nice for us to perform quick tests and quick benchmarks and reproduce the results. So here, that's nice, but we still have internal challenges. As I said, we have different challenges concerning the multilingual aspect that Deepbody doesn't cover, and we will see exactly what are these challenges. So the multilingual challenge, because Deepbody actually at the end fine-tune requires a manually annotated dataset to fine-tune on a target specific task. So we still have this problem to be able to perform multilingual sentiment analysis without the need of manually annotated data. And we have also a second problem, a second challenge. We need to handle at least 1,200 documents per second without making our hardware costs burning. And we were assuming that by LSTM would not really be an option. We weren't sure yet, but we were assuming that. And why? Because of our limitation and our resources. Our research environment is composed of 4 GPUs, and we mainly work with Keras and TensorFlow frameworks. Why? Because our production pipeline is built upon the Java virtual machine, and TensorFlow is the only one that offers an almost stable Java API. Onyx and Deep Learning 4G are not mature yet. And because of our production environment, we have CPU-only production instances, and our current implementation pipeline is built upon the way it is built upon the Apache Storm framework. We are not able to handle batch computation. So you guess that CPU only and one-by-one inputs, that's not ideal for deep learning models. So knowing that we have to our disposal Deepmoji, knowing our internet challenge, we imagined an idea, and we knew that emoji are universal across the language. It means that all the different languages use the same basis of emojis, and they are more and more used on social media data. So we imagined something. First, a model that is able to translate and code a text into a probability distribution of emoji. This is exactly the Deepmoji model, the pre-trained Deepmoji model. Okay, so let's imagine that we can build a second classifier that is able to learn from an emoji probability distribution to decode this encoded emotional context to a sentiment. Well, as this dog to emoji that we will call now, dog to emoji model, it's really easy to train another model on French data, on Spanish data, because we've got a lot of social media data that contains emoji in the different languages. So we can then train different models, for example in French, that will learn to encode French emoji probability distribution, and same for the Spanish. And in an ideal world, we would like the model that was pre-trained in English with English emoji representation to be able to automatically generalize from French emoji probability distribution and Spanish emoji probability distribution. So thanks to that, we would not have the need to have manually annotated data for sentiment analysis in French and in Spanish. So once we created this idea, we tried to validate the first approach, which is this one. Okay, train a model that will be able to decode emoji probability distribution into a sentiment, for example. So we took the Deepmoji pre-trained model that predicts emoji probability distribution is open source, and we simply built a multi-layer perceptron that tries to predict the sentiment from the distribution. And we observed that compared to the results with fine-tuning Deepmoji, we were losing with this method only 2 to 5 points of accuracy. So it was we considered it acceptable. And so once this was validated, we also needed to validate still the multilingual approach, but also the computational approach. So we decided to start with the computational approach, and we tried to reproduce Deepmoji pre-training on our own English data. First issue that we met, one epoch of training for 12 days. So that was long, okay, but it would be okay for us. But the second issue was a real problem. Inference time in the production, on the production CPUs, 50 milliseconds per input. And this is way too slow. For us, it would be nice to have a model that would be at least 7 times faster. So, at this point, we validated the approach that we can decode from an emoji probability distribution a sentiment, for example. And we saw that, unfortunately, we couldn't use an recurrent neural network architecture into our production. So we needed an alternative, and we needed to start again from zero. To do this, we stated two questions. Can we replace the Deepmoji architecture with a computationally cheaper one while preserving a good emotional context representation? Because this is our goal. And on the second question, can this emotional context representation using emojis be used to perform multilingual sentiment analysis? So that's the second part of our problem that we didn't validate it yet. So that's our approach. We call it Unimoji. You have the scheme on the right to see where we are and what we are trying to solve. So we replaced the 2 layers VLSTM with attention with different CNN architectures. We tried different architectures, and we ended up with our finite architecture, which was a combination of attentive convolutions and a 2 layers CNN architecture. That was used by Swiss Cheese, the winners of the same eval task 1A, sorry, of the 2016 competition. So this is our architecture that we use, and the attentive convolution layer is quite simple. You've got an odd kernel size, and you're taking the same number of left neighbor and right neighbor in your convolution operation, but you add the context vector that was computed before to this convolution operation. So that's it. And what are the results? So as I said earlier, we trained on our own data set, so it was only 512 tweets. The training time was only 44 hours per epoch compared to 12 days. And the predict in production was quite nice because it was 10 times faster on CPU. But let's look at the results. Our approach, convolutional approach, was better on the top 1 prediction for the emoji prediction, and quite lower on the top 5 accuracies. But you see that it's quite the same, but the real question is the representation of this new architecture still encode enough emotional context to then build a classifier upon it to realize opinion mining tasks? And that's what we try to solve. So we also build for Deepmoji, we built 2 layers neural network, and we compared the quality of the learned sentence representations by the different architecture of Deepmoji and the CNN architecture. benchmarking over the DeepMoji data sets. So on the left you've got the data set, and on the middle you've got the model that was fine-tuned. So on the left that's the real results of DeepMoji. On the right our CNN architecture that was fine-tuned also, and on the right you've got the DeepMoji and CNN architecture with this multi-layer perceptron that was inferring sentiment only based on emoji probability distribution. And so the first, we could answer positively to our first question. Can we replace the DeepMoji architecture with a computationally cheaper one while preserving a good emotional context representation? So yes. So now let's go to the fun. The second question: can we perform actually multilingual opinion tasks? Because that's the real point. So to do that, we trained 3 new dog-to-emoji models in French, German, and simplified Chinese. And we made our experiments on sentiment analysis and emotion detection tasks. So first, we needed to train the multi-layer perceptron to learn from emoji probability distribution a sentiment. So we trained it for sentiment on the SEMEVAL 2016 task 4A, which has 3 classes: negative, positive, and neutral. And for the evaluation, we didn't find a relevant data set that had the same 3 classes in all the languages. So we internally annotated data in English, German, French, and Chinese, and we measured the results against our previous algorithm. You can see that we've got some accuracy improvement, and which validates the multilingual approach, except for Chinese. And this drop is quite high, minus 30% of accuracy, resulting in 40% of accuracy in total, against our previous algorithm. So that was quite strange for us. And we actually discovered that the emotional context in which emoji are used in Chinese is really different from the emotional context in which, for example, English people is using. So that's a real problem, and that shows the limits of our approach. But we also tried on another task, emotion detection. So same, we had to train a multi-layer perceptron to decode the emoji probability distribution into emotions. We used the SEMEVAL 2018 task 1EC dataset, and we kept only 7 emotions that was interesting for us in terms of business: anger, fear, disgust, joy, love, sadness, and surprise. I remind that it's a multi-label classification, and as for the sentiment analysis, we also perform internal annotations on the 3 dataset: English, German, French. We actually dropped the Chinese model. And here are the results. For us, we considered that these results were good for our business case, because we didn't have this feature in the product yet, and we considered that by annotating new data, by tagging new data, we considered that this was good enough for us to validate our approach. So we validated our approach through these 2 questions, but with an exception on the second one. Our approach won't be able to work if the emotional context in which the emoji are used in a language is too different from the language that the multi-layer perceptron emoji to task was trained on. So far, so today our Unimoji model is running in our production pipeline for 6 languages: French, English, Spanish, Portuguese, German, and Italian. And for the for the simplified Chinese model that wasn't working, we didn't throw it to the dustbin. We just chose to fine-tune it on a Chinese sentiment analysis dataset, and it improved the accuracy on our previous algorithm to by around 20%. So it was around 90% of accuracy on the dataset. And we plan obviously to add more language to the model. And what are the key takeaways? So we developed a 10 times faster doc-to-emoji architecture based on convolutional neural networks with only small accuracy loss compared to the recurrent neural network two layers BLSTM with attention. We also created a modular architecture that we call the DeepMoji, where one can change either the first model that translate a sentence into a probability distribution of emojis, and the other emoji to task model. And finally, we have now a better algorithm in our production pipeline for sentiment analysis, and we have a new feature, emotion detection, that wasn't present yet. And these two models are based on a single probability emoji representation. It uses the English probability distribution, so that you don't need one model for sentiment analysis, one big model for sentiment analysis, and one big model for emotion detection. And also remember that the doc-to-emoji architecture can still be fine-tuned for any language if you have a reliable manually annotated data set. And obviously this approach is not perfect. We've got some limitations. As I said, if there are two different contexts between the use of emoji in the languages, and also if you have some different in your training set, highly different emoji distribution across two languages. So what's next? Well, we plan obviously to add more language. We will continue to explore limitation, and as I said, this project was launched before the arrival of all the cross-lingual models, and we might abandon this idea to continue to explore such cross-lingual models such as Laser or XLM. And maybe we will add some new opinion tasks, sarcasm detection, hate detection, optimism, pessimism. Thank you.
Thank you, Alexis. So we have time for some questions. Yeah.
Yes, and thank you for the presentation. If I understood correctly, there are 2 steps. One is doc to emoji, the other is doc to sentiment.
Yeah.
For the simplified Chinese data set, have you tried to fine-tune the second step? Because you only mentioned fine-tuning the first step, actually.
Well, it's complicated to fine-tune the second step, because the second model was. I see what you mean, but in this case, that's better to fine-tune directly your big model instead of having your big model that translates into emoji and have that manually annotated data set, for example, in Chinese. So you will pass your data set to be encoded and retrieve the encoding, and then fine-tune your second model on this encoded probability distribution. Yeah, but then it's better to fine-tune, because if you have a manually annotated dataset, we showed that it was achieving better accuracy to directly fine-tune the first model, because in both cases you will need a manually annotated dataset.
Yeah, because the second step is actually different for different cultures. For example, in Chinese, like a smiling face might not show that you're Chinese. So basically, for the second step, you can have this for your
Right.
representation, one for representation, one for error.
Yeah, we will try. We are actually trying to find different culture representation that are using emojis. So we can extend our model to different unimojis, like for example European unimoji, Asian unimoji. But we didn't try it yet. Yeah.
What about probability, subjective, objective? Because you have some contents who have multi-language, for example, and you have some contents who are really like close to sarcasm.
Yeah. That's another limitation of the model. If you've got informative text, it won't be able to get that it's actually informative text. So we are imagining a classifier that will first classify the text, whether it's objective, informative or not, and then we'll go through this unimoji approach as in general you want this not the informative text to be sentimental. So we plan to build. We are actually building a classifier before this to pass through Unimoji only if it's an objective post.
Test your model against translation.
No, we didn't, because we were not interested in, like, for the business case to translate yet. So we didn't try that. Yes?
For model 2, you have five for each languages, you have a distribution, emoji distribution.
Yeah.
And you use this as analysis for your next model.
Yeah.
Then introducing bias for every one of those distributions into your next model. And so you can basically, that's the problem arise for Chinese is because like you actually differentiating all of this distribution
Yeah.
your initial data set, then you will not go to Chinese.
Yeah.
So why do you try to use like some aligned corpus, or try to have like one distribution for like any of the languages? So you take the language as an independent corpus. You don't take the language as a parameter.
So you mean having only one doc to emoji model, a universal doc to emoji model, and that is then fine-tuned? Well, yeah, yeah.
So you use just one distribution, no matter the language.
I don't remember if we tried that, but that would be a great idea to test. Yeah. Maybe that's because we didn't want our vocabulary to explode, and so our size of the model that is exploding. Yeah. Yeah. So we preferred. Yeah, that was the point. So we preferred a smaller architecture that introduced, as you say, bias, but that was computationally efficient. Yes? Our previous model before introducing Unimoji was based on the fast text and oh, sorry, and it used the emoji, positive emoji set and negative emoji set as training. But no, we didn't try it because we were wondering that typically a model such as fast text wouldn't be able to encapsulate many emotional contexts. When we tried, to put fast text, as you might have seen in the slide, there is the fast text benchmark predicting the top 1 and top 5 emojis, and then when you're fine-tuning on the emoji benchmark dataset, in general it was around 90% of accuracy for the deep learning models, and fast text was like at 60%, so it wasn't working well.
Last question maybe? Okay, so thank you, Alexis.
Thank you.
Now we go for second talk. So welcome Benoît, Sacha, and Tom from Quantmetry.
Ah putain mais ouais, c'est ce que je fais pas me faire ça.
Okay, hello everyone. We talk about medicine today. Who we are. Okay, I'm Sacha, Tom, and Benoît. We talk about a complete project we developed. We come from Quantmetry, who is a company, data science company consulting, and we talk about a complete project we developed at Maïf. Maïf is, for people who don't know which is a global French insurance company located at the city in Niort, at the French center, West Center area. So why a complete project? Because we want to present you a first step of the project of a proof of concept, and we will explain just after what's the business case and what was the goal. The second step of the project was to implement and to pass into industrialization step the business case, and actually today the advisor of Maïf use it daily. And the third step was to open source complete package, a Python library, and we'll make a dedicated complete part about this just after. So we are at Quantmetry. We are a team of data scientists, architect, engineer, and consultant. We try to make sticking to the state of the art, but mainly we apply state of the art into a concrete business case. And these two examples are example of what we did inside our practice, dedicated practice NLP at Quantmetry. So, for example, the first example was to apply some techniques to summarize texts, and also a lot of text comments about the Grand Débat. So it is we provide a lot of things inside our GitHub. And the second part is medicine, so we dedicate a complete part to the sector.
So, hi everyone. So now I'm about to give you an overview of the project, so the context, the issue to solve, and the solutions we implemented. So Maïf receives daily about 15,000 emails per day. Oh yeah, daily. In one inbox. So those emails are from their clients relating to questions about their contracts. So it could be vehicle contracts, habitation contracts, reservations, etc. And depending on the content of the email, each email has to be routed to a different identity within Maïf. The thing is that the advisors that are processing the emails and then replying to the clients are only trained to process emails that belong to their own entities. So if they receive an email that doesn't belong to an entity, they have to send back to another one. The thing is that sometimes they're wrong also. So some emails can end up being routed like 8 times in a row, leading to a processing time of over 20 days, which is not acceptable. And also the old routing system was pretty outdated, and almost 50% of the emails were routed in the wrong entities. So what we had to do was to help Maïf to decrease the processing time by first implementing a routing, a classification model to help the routing of the emails, and then a summarization model to help the advisors better prioritize the emails they have to process without having to open the email and read the whole email. So now I give you a quick overview of the data. So we had almost 3 million emails from 2017 and 2018. out of which over 600K were within the project perimeter, meaning that we could use them to train our classification model, but we could use the whole amount to train the embeddings. And then all the emails vary in length and complexity, but the median count of words is 112 words. So basically, so now I'll give you the structure of the email. So each email follows a well-defined structure. So one email is actually like a conversation, a history of messages. So you have one first message and then some replies or transfers, etc., with usually some metadata with your transfer or your reply. And each message follows a defined structure. So with first a hello, then a main body, then some greetings, a signature and footer sometimes. So the processing step is about taking out of the metadata and the body of the email the useful information.
Thank you. To us, the pre-processing was a very important step. So we invested a very large part of our time in the pre-processing. So at the beginning, we have an email in French. And just as Tom said, when an email is an answer to another one, you have in the body the whole conversation. So the first thing that the pre-processing of Meetup does is to split the conversation into messages, the first, and the last one, and the previous one. And then in each message, it puts tags on recognizable parts. Here you have hello parts, some greetings, signature, some footers. And now the email is well structured. Every further steps will be very, very easier. Because now we can focus on the parts that we are interested in. Most of the time, the parts that we are interested in are the parts that are between the hello and the greetings, because here are most of the time the information we want to interpret. And when we do that, when we focus on the parts that are between hello and greetings in all the conversation, we observe that we have removed nearly half of the words, which is very important in the further steps and the further models, because less words are less parameters, less complexity, and it's very important to have great models after. After that, we apply some traditional cleaning, like capital letters to lowercase, and the accent are replaced. And we put together some words into well-known expressions like conversation téléphonique or 6 juin. And finally, we tokenize it with a regular expression. By the way, in each step of our pre-processing, we have many regular expressions. Everything is about regular expression in that pre-processing. So to any beginner in NLP, we would say, know how to design your regular expression. It's very a must-have. You can't afford it before to be interested in the deep neural model. First, try the regular expression. No, not yet. Thank you. We decided to structure our pipeline in such a way each step occurs just once and at the perfect moment. For example, we couldn't have made some typography cleaning before the splitting of the conversation or the parts tagging, because we need the typography to do the cleaning of the conversation, not the splitting of the conversation and the parts tagging. So it demands more work and a discipline, but we think that the structuration of the pipeline is really a good thing, because we appreciate now a clear and ordered pipeline with no backward. It's very important. there is another best practice we would like to share. In Melusine, we are using many libraries that are open source on Python, like NLTK, Gensim, Keras, Spicy. So we have to be careful with interoperability. If you have ever tried it, you can try word ending on Gensim, and Gensim will build a vocabulary, and then you use this word ending on Keras, and Keras will build another vocabulary. So you have to make sure the vocabulary is the same, because if they are not the same, there will be mismatch. It could be obvious, it seems obvious, but it's very important. But there is worse than have different vocabularies. You could have multiple tokenizer, and we think it would be a mistake. And if you are using in a part of your project NLTK tokenizer, and in the other part for modeling the Keras tokenizer, there is no coherence. There is a lack of coherence, and we think it's very important to insist. So there is one solution to avoid this little mistakes. This solution is to design your pipeline that way, as we just said, and to go until you have an already tokenized text, and to make sure that you never use text as input to Gensim or Keras, but always use an already tokenized text. So you have coherence, you are sure that in all your project you don't have mismatches between vocabularies and tokenizer. As Tom said, we are doing email classification for the routing. We have tried several approaches. The first one is based on a bag of words with TF-IDF weights. And the second one was about weight embedding, and the words were weighted by the TF-IDF score. But we rapidly observed that the neural nets approaches overperform largely. The recurrent neural network and the convolutional neural network had the same performance in accuracy. And finally, we decided to put on production just the CNN, because the prediction time was faster, and to us it was simpler to explain what are convolutions on text than explain how works the recurrent neural network. Okay, next. Thank you. So let's focus on this convolutional neural network. We are not here to explain what are convolutions on text, but rapidly a convolutional neural network will find some local patterns in the text. So in the text, a local pattern is a sequence of words that is characteristic. And finally, it will use these local patterns to make some prediction. And after the convolutions, we add global max pooling. There is an invariance to the position of the pattern in the text. So because of this invariance, we can think that the CNN is quite like the bag of word approach. But contrary to the bag of word approach, the CNN uses a dense representations of words, which is very powerful, and we think this is the reason why the CNN outperforms the bag of word approaches so quickly. And in addition, we add some metadata in the dense layers. So the metadata are the date, the hour, who sent the mail to who, and other metadata. And we observed that the adding of the metadata improved the performance by 5 points. on our model. It was very useful in our case.
So now I'm going to present you the summarization model we developed. So first, because we wanted to industrialize our models, we need something robust. And for this reason, we took an extractive approach in opposition to an abstractive one. So our model is based on the extraction of keywords from the email and the nominal and verbal groups surrounding them. So it works in 4 steps. So first, we build the syntactic graph of each sentences within the email. So you check if for each word if they are like a pronoun, a verb, etc., and the type of relationships between them. Then you would identify the keywords we use the classic TF-IDF score. And then once you identify your keywords, you just read through the graph to extract the right nominal verbal group, and then you can the rest. So I give you a small example. So you have this email in French. Bonjour, j'aurais comme chaque année besoin d'une attestation d'assurance concernant l'appartement où je suis locataire, 11 rue d'Anjou, la code postale, Marseille pour 2018, etc. So we identify 3 keywords, so attestation, assurance, appartement, and then we can extract the rest and obtain besoin d'une attestation d'assurance concernant l'appartement Marseille pour 2018. So here it's a very short email, so it doesn't add much, but on longer emails, it was pretty useful. However, on the test sample, we got only 70% success rate, and because we had to industrialize this model, we had to drop the extraction of nominal verbal groups part and focus only on the keyword identification. But to improve our results, we had to inject some business knowledge. So we had some talks with the advisors to define a list of keywords, so that we could select some words even though they had lower TF-IDF scores compared to other ones. So now I'll give you a quick overview of the industrialization process. So first about the coding architecture. So the main things that we have a unique architecture that works on the data lab server for the training phase. So we could train our CNN with GPUs. And for the production phase on the legacy server, that is much lighter to do all the predictions with on CPUs. And it all works with one single pipeline. And then just quickly the tools we use to industrialize. So we use Jenkins, so a continuous integration tool. And basically it's pretty simple. So when you work on your dev branch on Git and you do a merge on the proper branch, it will trigger a build with Jenkins that will deploy the API and the model on Docker containers that will be themselves hosted on Rancher. And if Docker is already active, it will be replaced without any service interruption. And then from then on, the API can interact with the model.
So now let's talk about Melusine. Melusine was the last step of our work. It was an extra mile after this project. With Maïf, we decided to implement and to develop an open source package dedicated on what Tom and Benoît said before. So it is a high-level Python library dedicated on French emails. It's global. We take a global step of the project, so you will find some pre-processing tasks to help you to pre-process your emails, and also email classification tasks, and also feature summarization tasks. So we are pretty happy about this success because of the number of the stars, but also because there are a lot of a little bit community behind of this project. And a lot of at Maïf. So if you want to explore our documentation or GitHub, please let's see. What you could find inside Melusine, we present the 5 sub package. You will find 3 main package dedicated to the main task. So pre-processing task, models, summarizing task. And also 2 sub-packages related to the NLP tools or utils and we will dedicate it a complete part on this just after. To illustrate it, you have an input main dataset. You want to clean it and to address a use case, so summarizing or make a classification. You have to preprocess your dataset, to clean your dataset. So you have to structure your conversation and mainly by using a lot of regular expression. And thanks to config subpackage, you have a lot of you can parameterize your own, manage your own parameters. So add your business knowledge, add your custom regular expression, and we will state it just after. We also have another features, which is a class to structure a complete pipeline and integrate it easily into a scikit-learn pipeline or whatever. We call it Transformer Scheduler. I will illustrate it and how it works just after. So it is a global picture of what Melusine does, and as you see, it's the same as we did that in the project.
So yes, one of the main challenges when designing Melusine was to remove all the business specificities from Maif out of the code, and let the any user add their own specificities from their own projects. So for this, we developed the Transformer Scheduler class, which enable anyone to add custom function, custom interaction to within the processing pipeline. So for example, if you want between the cleaning step and the tokenizing step, if you want to extract all the phone numbers, let's say, you can use this class to add your function and do the whole pipeline.
As Sacha and Tom said, the code was designed to be customized by the user. So you have a conf file, and you can modify it. If you use Melusine for preprocessing, for example, we recommend you to leverage it by designing your own conf file, and as you add your custom regular expression. For example, in Maif, there is a greetings salutation mutualiste or sentiment mutualiste. So we made our own conf file, and we just added the regular expression in the part greetings. So now we've leveraged Melusine, and we recommend you to do the same thing when you are using it. Thank you.
And we would like to share with you feedbacks and best practices about open source, and when you want to open source a project, what we recommend to do is take a lot of time before the development phase. In fact, we have a big picture of what we did, so it's easy, but take a lot of time to define and well-define the functionality of your package. Write pseudocode, but don't code. And it's really, really important to really give a big vision or structure of what your package do. During the development phase, we would like to share just some tools. We recommend some, for example, Cookie Cutter, which is tools which allow us to start a project with a complete template, with a lot of files, really useful. Another thing, so like to use virtual environment or unit testing, and also versioning your package is very important. And after the development phase, take a lot of time to document, because it's the last thing, it's what the user see. So take a lot of time to document not only your code, but what your package do, with by giving a lot of example. It is a really, really good thing, and we recommend to do that and take a lot of time. So basically, we pass not much time in the development phase, but most of the time before the development phase and after the development phase. So feel free to contribute or simply test it, install it, use it. put stars inside our GitHub. And of course, Maïf at Niort and Paris and Quantmetry still recruiting. So if you are interested, we can just discuss after the talk. Thank you.
Are there any questions?
I'm just thinking about define your subtitles out. So one of the challenges of using part-of-speech tagging on less formal text, like for instance the email, is that the accuracy is not up to the level that is when it's trained on more formal text such as the news, wire, or anything. So did you do anything to tackle that, and how do you address that? The challenge of using part-of-speech taggers that are trained on a formal text, and we have to use them on less formal text.
In Melusine, we didn't use part-of-speech features, if it is the question to make our predictions. It could be an area to dig, but no, we didn't do it.
How did you manage to convince your company to open source it? Most companies don't want to spend that much time on open sourcing.
Good question. So, I mean, it's actually like Maïf, the client who has a project with Maïf to open source it, to contribute to the community and show the technology of Maïf.
It's not the first project Maïf gives to open source.
Yes, but it's the first in Python.
Yes.
Did you test it against spam detection? Or is it a project?
No, we didn't test it. No.
But you can try it if you want. Use the package and process your data and make your own classification. It's really
it's lookable. What? The classifier is lookable?
Yeah.
Hook it, I mean?
yes.
Yeah.
How do you handle bad words, bad spelling and so on, mistakes which are quite frequent in emails?
Today we haven't a miracle solution to make it, but it would be possible to replace word-to-vec first word ending with fast text, because there are some parts of the text that will be present in the misspelled word. It could be possible. You can customize Melusine and replace some modules, and maybe it could be possible. Yes.
Yes. You try to compare your approach for pure extraction using KFIDF with other methods like cross-base, like PageRank, PageRank, SilverRank. Did you compare it?
Can you speak louder, please?
Did you compare your method for pure extraction with other methods like extract, SilverRank, and Square?
No.
Is there a particular incentive that you need this method for your because it's faster or less expensive?
I don't know. Maybe. We'll
Yeah.
try. Text rank. Okay. Yes.
Will the package still be maintained after it's open source?
Yes. So Maïf and Quantmetry will still be maintaining it. Yes.
How is it to extract emails from Outlook? Is it easy task to extract all emails? Or do you have to work on some Outlook aspects to extract them? I recommend not everybody to do it.
Sorry, I didn't understand.
Let's say you have an email address,
Yeah.
and you have a lot of email coming in. How easy to extract the emails from your Outlook email address or Gmail or
So So yeah, so those emails has to be already extracted.
Okay.
So you package it and you have to extract them yourself. And that now if we have the that's already done actually. So
Yes.
Okay.
It's mainly task, but it's very difficult, not too difficult, that you have to go to Gmail or whatever to extract your emails and put in the format, well-defined format.
One last question. Okay, thank you very much. So I think Damien has an announcement. Where is Damien?
Samama.
Merci. Je voudrais commencer simplement juste par remercier aussi Alexis qui s'occupe d'organiser l'événement. Et moi, je vais assez régulièrement. Je ne sais pas si on a beaucoup l'occasion de l'apprécier. Donc, merci beaucoup pour l'organiser. Il y a des choses intéressantes. Une deuxième chose, j'en profite, je vais vraiment pas être long, pour redire quelque chose que j'avais déjà dit quand j'étais venu il y a un moment, c'est qu'il y a aussi, plus sur les aspects académiques, étudiants, une association qui s'occupe de traitement automatique des langues, qui s'appelle l'APLA, et qui a un site sur lequel il y a des annuaires, par exemple, des formations, mais aussi des entreprises, donc c'est des entreprises qui ont une grosse équipe de l'État et de l'ESPI, donc n'hésitez pas à demander à figurer dans l'annuaire. Et puis je voulais surtout faire une annonce parce que cet été, donc, il va y avoir un hackathon qu'on organise depuis 4 ans en équipe. Et donc cette année, on va le refaire, ce sera début juillet sur Toulouse. On va avoir 2 tâches. La première, ça va être sur le grand débat national. On va proposer une tâche de génération automatique par rapport aux contributions qui ont été faites. L'idée, ça va être d'essayer de générer une phrase à partir de quelques mots qui sont donnés et un peu de contexte. Et là-dessus, on va avoir un leaderboard et des équipes vont être évaluées et classées pendant l'événement de façon un peu interactive. Et on va avoir une deuxième tâche qui va être d'essayer de construire des chatbots sur le domaine du juridique. Donc, comment est-ce qu'on peut faire un système interactif on pose des questions sur un problème juridique particulier et essaye soit d'apporter une réponse ou de donner un lien vers des éléments qui nous permettent d'avancer sur sa recherche. Voilà, donc ça, ce sera le 1 et 2 juillet, et puis voilà, si vous voulez en savoir plus, ça s'appelle le hackathon, et évidemment, tout le monde est bienvenu. En général, c'est challenging, intéressant, puis un peu comme pour les meetups, moi je trouve ça pas mal de temps en temps de sortir un petit peu de son bain, d'aller voir un petit peu ce que font les autres, rencontrer la communauté, etc. Donc là aussi, c'est une autre occasion pour faire ça. Merci beaucoup pour l'attention.
Thank you everyone, and thanks again Link Value, and I think they are offering us some pizza, so you are welcome. Thank you.
Thank you.